We're Team Ensemble Automator, and we've developed an uncertainty quantification framework for any ML model. Before delving into the specifics, why do we need to quantify uncertainty in the first place? Well, the core goal of ML is to make predictions. Since these predictions are made on unseen data, we need to evaluate our model's accuracy on test distributions. The major problem with that is these results are binary. This leads to AI systems without proper accountability. Uncertainty quantification helps us understand the reliability of a model and gives an explanation to the end user why it made the decision it did. Now, you may be wondering, why not just use a generative learning algorithm like naive Bayes or GDA to solve this? The problem is that these algorithms need access to the underlying prior distribution, which may not always be the case in most real-life scenarios. To solve this, we make use of the idea of conformal predictors that make predictions according to how similar the current observation is with respect to other data points. Based on this notion, we've developed this idea of p-value, which receives credibility level representing the confidence of a prediction above a certain significance level. We've used our model in various applications such as image classification, sequence prediction, robotics, and risk analysis, and as you can see onto the table, leveraging our techniques via conformal prediction generated better results in every case. So without further ado, let's showcase some of our results using conformal prediction. In light of COVID, we built a CNN that could detect if a CT scan was COVID positive or negative. As you can see onto the graph to the right, as the model became more confident about its prediction, the results improved. Leveraging our technique is also a viable solution to check for IID in datasets, as you can see from the graph to the left that the confidence level follows a normal distribution. Using our model to evaluate credibility of loan prediction is a great idea, as we've shown that as the model's confidence increases, the percent prediction accuracy also improves. This can be useful for companies like Capital One or Wells Fargo that would now have to spend less time manually checking for loan insurances. We've also proven that this technique is not limited to just structured data. This is good news because any of you can use your existing model and feed it into our network, and it would automatically help you interpret your results. Here, as you can see, there are two different agents trying to land between the two yellow poles, and we've shown that as the model becomes more confident about its next action, it tends to make better and more reliable decisions. It is very important to realize that these agents were trained without any prior human knowledge or rules fed into the system. These so-called reinforcement learning agents learn to fly based on thousands and thousands of episodes of self-play, using policy grading methods based on actor-critic algorithms. We can also leverage these reinforcement learning algorithms like actor-critic to help build better explainability models, like what were the most important factors in the machine learning algorithm making its decision. And that's it for Ensemble Automator. Thank you.